Okay, the how, 90 degrees counterclockwise. That's the way we go. We have our formula, right? We know that 90 degrees goes with this. A, B, negative B, A. Okay, basically I know 90 degrees counterclockwise should put the shape, since it's all in this quadrant, it should put the shape in this quadrant, right? Because that would be 90 degrees to the left. NASCAR style, right? So I'm just going to do this. I'm going to start with S because that sounds fine. It doesn't really matter. S, this is 1, 2, 3. 1, 2, 3, 4, 5. Is this point S? Okay, I need to do this to it.
It's negative 3, 5.
Thank you for fixing that. Negative 3, 5. Now I'm going to do S prime, and then we only have to do S prime. I have to switch the order. So this will be negative 3, and this will be 5. And it also says to make that into a negative, to do the opposite. So now I'm going to graph this point. Negative 5, 1, 2, 3, 4, 5, and down 3. 1, 2, 3. This becomes S prime. Okay? And so I'm going to flip this back up. Let's see how this works. I don't think I can do this. Okay, do we see now that that S is the same place as my S? Do I need to do that for each additional one? Yes. Okay, so this does take some time. I know it's 12 problems. It does take a little time. So we can do that for T as well. T would be 1, 2, 3, 4, 5. That's negative 5. And that is 1, 2, 3, 4. That is 4. I need to flip the order. 4, negative 5. And I'm supposed to, based on this formula, change that to a negative. So T would be negative 5, negative 4. Did I do that right? Negative 4, negative 5. Okay, I did that right. I just said the wrong thing. This would be T prime. Okay. And then honestly, R, there's a cheat on R because R is on the axis, so it's real easy for me to see. If I spun this 90 degrees, literally what I'm doing is this. That's what the answer is going to look like, right? Because that's what spinning at 90 degrees looks like. So if you can see this in your head, you can just transfer. But if I spun this 90 degrees, this R, I know that it's going to go 2 away from this spoke, 2 away from this spoke. This is going to be R prime. You can also do it like this. I just want to show you something different. Okay, and another way to do U, if you don't want to do this formula, it basically is on this spoke, but one up. So 1, 2, 3, 4, 5, one up. So it's going to be on this spoke. Did I connected the dots wrong? I connected the dots wrong. Oh my. So that's what I get for trying to do it without doing this, right?
I feel so dumb. You know what though? It's okay because you have the actual answer.
Right. So we have the actual answer. What did I miss? I didn't mess up anything. That's the answer, right? No. Oh, no, I counted too far. It's supposed to be here. Oh, no. Okay, and again, I'm going to show you the actual answer here. Where is it? Okay, but again, the way I like to do it, honestly, because this paper, and this is why I like this, it's not your textbook, it's not a million pounds. If I'm rotating 90 degrees, it's going to look like this. That's how it's going to look. And you can't see that. But you can imagine what it would be like if you could. Where'd it go? Okay, so that's 90 degrees. That's regular. 90 degrees should look like this. Okay, does that make sense? Okay. Hopefully that helps with rotation. But seriously, This is why I gave you those formulas. Just so you could take each point and be able to rotate it and not eyeball it, because I eyeballed it and I messed up by 1. It should have been there instead of there. Okay, if you mess up by 1 on 1 point, am I going to take all the points off on it? Maybe not all the points, but I'll take points off. Okay.
I didn't make the original points negative, that's why I
And what's important to me is you getting it right tomorrow. If you get it wrong today, who cares? You get it right tomorrow, and that's what matters. All right, I don't remember where we were. Where were we?
2.
Oh, okay. That's fine. We're on 2. It's there somewhere. Trust me. 2. Okay, pretty good. Remember, x equals 2 is going to be a horizontal line on x equals 2. Vertical line on x equals 2. Right? Vertical line on x equals 2. What do we got here? So this is the same thing with the rotation, except for you use the formula -a, -b. So you switch the order and switch their signs. This one's easier to see, I think. And again, I can do this with the worksheet to see what it's supposed to look like, so I know if I'm right. Here's my worksheet, and I'm going to rotate it 180 degrees. Right? Because that's what you're doing, right? Okay? And we're going to use that strategy on the back as well. There we go. 5, and there's formulas for the reflections, and here's 6. Okay, I'm going to do the grading of the next part where we're just actually going to think this through. On 7, what does it look like? I got 3 choices. It's multiple choice. Okay, it's definitely not a translation because it doesn't look like I slid the same shape. So, I know what you said. You're right. You said reflection. But I'm just going through the thought process. It kind of looks like reflection to me. It might be rotation, but one trick I do with reflection is I take a little piece of paper, and so I like, okay, there's a shape. It's hard to do this on camera. There's the shape. Does it look like there's a mirror right there between the two? Okay? So it is a reflection, and it looks like the reflection is right here. And that mirror would be what? Okay. Another way to tell if it's a reflection, I think it's a reflection, I think it's y equals x. Then I have a formula that I could test it. Okay. Here's my formulas. I think, right? That's a rotation. So I need to make sure I got the right formulas. And so these are the formulas I need, right? So you have them somewhere in your notes. Y equals x. Basically, it says to do BA. So let's see. Let's look at x and see where x ends up. X is 1, 2, 3, 4. 1. According to this, if it's a reflection about y equals x, it should be 1, 4. For my prime, let's see if it is. 1, 1, 2, 3, 4. Okay. That proves that it's a reflection, right? So that's how you do it if you're unsure. Use those. Do I have to test out every single point? Probably not. Probably if I get 1, it'd be fine. All right, let's look at 8. What do we think? Not a translation because it clearly doesn't look like the same shape. It looks like 90 degrees. Makes sense because this eye rotated here. If it's 180 degrees, that eye would be somewhere over here, right? If it's 270 degrees, it would be somewhere over here.
So, if it's for the 90, 180, and 270, if it's a rotation at 90 degrees, it's always going to be in the
above it?
Yes. So
That's how you can prove
because a 90-degree spin is like this. Okay? You see how my original came down here? And so, yeah. So if you start here, 90 degrees would put this entire shape here. 180 would put the entire shape right here. And 270 would put the entire shape right here. Where it gets hard is if we have 2 points here and 2 points here. These 2 points with 90 degrees would go here. These 2 points would go here.
Is there any other way you can prove that? 'Cause
Yes. Again, when we're thinking rotation, we have formulas. And that's why I teach you the formulas, because eyeballing it is what I'm doing right here. That is effective because this is a real thing. But the formulas are how you kind of tell things to do it. So if I think this is a 90-degree rotation, I'll take J. J is 1, 2, 3. 1. According to this, negative BA is for 90 degrees. So that means I switch the order and change this negative. So let's see if that works. This is for, which one was this, J? J, and this is J prime. So let's see.
it's -3.
Is it negative 3?
On J. On the first day.
Oh, the first J is negative 3? That would change a lot. So then negative 1, down 3. Okay. So I used the rule, and it does look like J did rotate 90 degrees. Does that make sense? Mm-hmm. So there's the eyeball way, which does work. There's the math way, which does work as well. And so if I took away the picture, you might have to do the math way. But I'm not going to tomorrow. All right, let's look at 9. What do we think? That's not 9. That's 11. Okay. It's definitely not a translation because basically the pointy parts of the shape are not facing the same direction. It doesn't look like I can draw a mirror anywhere, so I think rotation. So B went 1, 2 away. C went 1, 2 away. So what do we think it is? 180. Can we prove it? Yes, we can use this formula here. Right? All right, this one. 10. Okay, this one just to me, and that's a problem with me, that it looks like a reflection. It looks like I could just draw a mirror here. If you can't see that, which some people can't, and that's fine. Okay, so it looks like the y-axis is the mirror. If you can't see that, you can use all these formulas just like we did to test it or prove it. But even when I go, okay, I think it's a reflection, let's look. That's 1 away, that's 1 away. This is 2 away, this is 2 away. Okay, and of course, once you draw the mirror in, it looks more like a reflection than before, doesn't it? All right, these are easy. It looks to me like I just slid my shape, but writing the rule might be hard. So I'm going to put these little guys there. So let's look and see where W went. Looks like W went, and you got to do it the right way. We start with the pre-image, and the one with the X prime, W prime, all that stuff is going to be the image. Actually, I don't like W because it's convoluted. Let's look at X. Looks like X went down 1, 2, and it looks like it went left 1, 2, 3. So left 3, down 2. Does that make sense? And last but not least, this is also translation because it looks like the same shape. We just scooted it down, right? Okay, did we scoot it left or right? Down, how many? 1, 2, 3, 4, 5, and 6. All right, I'm gonna show you the actual answers. Yeah,